There are a couple of different factors that affect the rates of reaction. What I'd like to do here is to go over these kind of quickly and go back and remind you of a couple of places where you might have seen these factors in action. One of them is concentration. So the more concentrated a reaction is, the more concentrated your reactants are, the faster the reaction will go. Surface area is right in there with concentration. Concentration is if you have two things in the same phase, like two things mixed together in solution or two solutions. Surface area when you have two different phases, like a solid with a gas or a solid with a liquid. An example is right over here with the iron filings. Okay, second thing is temperature. If you heat up a reaction, it goes faster. You cool it down, it goes more slowly. And the third thing is a catalyst, and we've seen a couple of catalysts in class so far. Now, one of the things would be concentration. When we did the elephant toothpaste, and this is not ours, this is from the internet, but when we did the elephant toothpaste, we started with peroxide, and we used 50% peroxide. No, we didn't. We used 30% peroxide, which we were able to buy from a supply house. The stuff you would normally have around the house would be about 3% peroxide, and that wouldn't do this demonstration as nicely. So 30%, so the concentration makes a big difference there. Another place is when we were working with our ornaments, then we had to do that into a beaker, and the beaker had about 3 molar hydrochloric acid. And if we used lower concentration of hydrochloric acid, we would have had to wait a lot longer. For our reaction, we only had to wait about 5 minutes. Another time we saw this was during Halloween. And during the Halloween lab, remember what we did is we had iron filings. No, we didn't. This is the part where we had a cotton ball, and the cotton ball was placed into a container containing about 100% oxygen. So we burned it in air, which was about 20% oxygen, and it burned normally, but when we put it into the 100% oxygen, we got a much brighter flame, and the cotton burned more quickly with very little ash. Another reminder here was where we're doing concentration, and this is more surface area. And in this case here, we're doing iron filings. So we saw that iron didn't really burn, but when you take the iron and split it up into tiny pieces, then it burns very quickly. So the more surface area you have, the faster the reaction rate. And again, this is talking about iron neutral, iron as a solid, mixing with the oxygen in the air, which is a gas. So we have two different phases, so surface makes a difference. Now, temperature is a big factor, and pretty much everybody knows that if you take a light stick and throw it in the freezer, that it gets very dim and it lasts a long time. So if you have it in normal room temperature or hot water, it would go really it burns out a lot faster but a lot brighter. But if you have it in cold, it lasts longer. And that's why we put stuff into the refrigerator, because we want the reactions that make things spoil to go much more slowly. The last one here is catalysts. And catalysts we have seen a couple of times way back in the beginning. Then when we were doing the elephant toothpaste demonstration, we were getting peroxide to break down, and we were using Ki, and it's the I minus in there, that's the catalyst. So we added Ki to this reaction, to the mixture, in order to make it bubble up a lot faster. During the summer, we did the micromole rockets, and so we used as our oxygen generator, we were using peroxide again, but in this time we were using yeast, and that created some water and created oxygen gas here that we're using to fill up our little micromole rockets. So yeast was a catalyst, iodine was a catalyst, and the last time is when we were doing the esterification lab, we were using concentrated H2SO4, 2 drops, and that's when we mixed together our acid and our alcohol. we were able to make the ester methyl salicylate, which smells like wintergreen. So we've seen that we have different kinds of factors that affect the reaction rate. We have catalysts, we have temperature, concentration, and in with the concentration is surface area.